When I was an undergraduate physics major, I was the only woman in my class. I was afraid to ask questions because I feared that my lack of knowledge would reflect poorly on all women. What I didn't realize then is that the other students in my class had gaps in their knowledge too. Why would we be taking classes in the first place if not to learn what we didn't already know? Now that I am an instructor, I see this mindset in my own students. Many of them are afraid to ask questions or to answer my questions. Many of them are reluctant to be vulnerable by admitting that they don't know everything. What does it say about us if our students are afraid to ask questions and make mistakes? What does it say about us if junior scientists think that making mistakes is unacceptable in science? In STEM, which stands for science, technology, engineering, and mathematics, it is important to ask these questions in the context of underrepresented groups. People from underrepresented groups often believe that stereotypes about their group's low achievement in math and science are real, that there isn't anything they can do to change these stereotypes. This is known as stereotype threat, a well-known phenomenon that is often made worse by making mistakes that should otherwise be a normal part of the learning process. People from underrepresented groups often are more susceptible to internalizing their mistakes. From the students who are just starting out to the most accomplished professional scientist, the culture of science does not leave a lot of room for people to acknowledge their mistakes. The way people engage with science is tied to whether they see themselves as doers of science. People who see themselves as doers of science are said to have a science identity, meaning that doing science is an important part of their sense of self. A science identity is one of the most important predictors of performing well in science classes and of having a future career as a scientist. If people believe that they are destined to be bad at science, then they will not develop a science identity, and their performance in science will suffer as a result. So many times I have heard people say, "I'm just not a science person," or "I'm just bad at math." Many of you may have said these things yourself. But research has suggested that there is no such thing as a math person or a science person. Research says that simply teaching students about malleable intelligence, or the notion that intelligence is not a fixed quantity and is changeable with hard work, is a tool that teachers can use to improve the students' confidence in their abilities and thus improve their performance. Consider that for a moment. Simply telling students that they have the capacity to change their performance makes them perform better. In most science classrooms, we aren't letting students know that it's okay to fail, make mistakes, or admit when you don't know something. But in science, it is necessary to fail in order to make progress, in order to discover things. The scientific method itself depends on failure. The scientific method depends on the idea that the process of inquiry is fallible, and that we must constantly refine and improve our ideas in order to make progress. In science education, we are trying to understand how to help students to realize that it's okay to make mistakes, or to admit when you don't know the answer to a question. A study published earlier this year looked at 3 groups of high school science students from low-income areas of the Bronx and Harlem. The first group read about the amazing, unbelievable accomplishments of 3 world-renowned scientists: Albert Einstein, Marie Curie, and Michael Faraday. A second group of these students looked at the scientists' personal struggles, such as the persecution that Curie faced as a female scientist, or the discrimination that Einstein faced as a Jew in Nazi Germany. The third group of students looked at the scientists' intellectual struggles, such as the point in Curie's career when she was having one failed experiment after another. The study found that the students who looked at the scientists' personal or intellectual struggles performed significantly better in their science classes. The students who had only read about the amazing or unbelievable accomplishments of the scientists and did not hear about the struggles did not perform better in these classes. In fact, their grades suffered. Highlighting the failures and the struggles of these famous scientists made students realize that these scientists are human beings, that they're not some special type of genius to whom they can never measure up. Changing the science education culture is a start, but we need to change the culture of science itself. Last year, I failed a very important exam in my graduate program. I was absolutely ashamed of myself. I called my friend Nicole and told her the news, and she talked me down, telling me that what I was going through was normal, that lots of people make mistakes, and that you need to make mistakes in science. I didn't believe her at the time. I couldn't really internalize what she was saying to me. So Nicole started a hashtag on Twitter called Failing in STEM. And her basic message was that we need to tell young people that it's okay to make mistakes, and that it's normal, and that it happens all the time, that scientists make mistakes all the time. Failing in STEM went viral, and stories started pouring in from scientists all over the world, stories about their past scientific failures. A few scientists talked about their experiences failing exams, and that made me feel a bit better. One scientist talked about how she was an astronomer, how she was observing at a telescope and taking a whole bunch of blank images and trying to diagnose what's wrong with the parts. But it turned out that the telescope dome was closed. A second person tweeted about this group of scientists who were studying space rocks, rocks from space, and they found a really important, amazing thing. They found organic material, which means signs of life, right? Well, it turned out that the organic material was from the container that was holding the space rocks, so kind of a big mistake. These scientists had failures, but these failures did not ruin their careers. In fact, they made them better at science. If scientists didn't have failures, if they didn't make mistakes, then we would never have discoveries. We would never know what works and what doesn't. I am simultaneously trying to instill this message into myself and into my students, and into anyone I meet, that we need to change our culture. We need to build into it a sense of resiliency and openness, that we can talk about our failures, talk about our mistakes. Failing in STEM gave me the perspective that I needed to see that being a scientist is not about getting things right all the time. It's about making mistakes and learning from those mistakes. So let's keep this conversation about failure going. Let's keep talking about this in our classrooms, in our research labs, and online, so that we can make the culture of science a more welcoming environment for everyone. Thank you.